Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to some basic concepts, introductory concepts related to mechanics, study of mechanics. In the previous video, we discussed, we covered the topics such as the categorization of the study of mechanics in three parts: statics, kinematics, dynamics. Then we discussed the concepts of point objects, frame of reference, the concept of rest and motion, magnitude and direction, all of that we discussed in detail. Basic understanding. In this video, we are going to discuss, the basic concept of rest and motion. Now we can say that when an object is stationary, it is at rest; when it is moving, it is motion. Yes, that is right, yes. But there are some factors, some things which we have to consider, bring it into consideration when we say that an object is at rest, when we define that an object is at rest, and when we define that an object is in motion, because these subtle differences can bring about huge differences when we try to quantify these this situation of rest and motion in terms of mathematical equations, derivations, all that. Okay, so we need to be exactly crystal clear when we say when the object is at rest, when it is in motion. Again, rest is of different types, we will study. Motion is of different types. So all that, those things we will cover. Okay, so we have covered these things: frame of reference, point objects, location in space, Cartesian coordinate system we have covered. So you can watch the first video where I have discussed those things. Now, simple things, simple way how we can say that an object is at rest when it is in motion. So simply, if we say that if an object, it does not move in any direction, okay, it does not move in any direction, then it is at rest. Okay, it is not moving at all in any direction. And if an object, it moves whether downwards, upwards, towards right, towards left, or in any direction at any particular angle, if it moves, then it is in motion. And it does so for a particular interval of time. Okay, it starts at some initial time, let's say ti, and the motion stops at, let's say, some final time tf. And for this time duration, tf minus ti, which is the interval of time for which it is in motion, that also is very important. So how we explain an object at rest, and how we can describe an object in motion, that we'll discuss. So the situation of rest, resting position of an object, it can be classified into two categories. First is absolute rest, second is relative rest. So before this, if you remember, I explained to you the concept of frame of reference and how for measurements, in mechanics we consider earth or ground as the frame of reference. So absolute rest, relative rest, it will bring those things. So first let us see what absolute rest is. So if both the frame of reference, that is with respect to the point or that space with respect to which we are measuring the rest or motion effect of the body or the object, if both of them are at rest, that is they are both not moving, then it is said to be absolute rest. So here, as I also used this example in the previous case, let us say we have block or a box on the ground, it is not moving, and we have on the same ground here, we have a person standing nearby. He sees that the box is at rest, it is not moving. So as both the person and the box, they are located at the same, on the same ground, earth, the same frame of reference, both are at rest. Another important thing, the person is also at rest and the box is also at rest. Both of them are at rest. This is the object, and for this example, let's say this is the reference point. So here both of them are at rest. So this is the concept of absolute rest only when we involve these two, things, these two, the situation where there is the person and the box. But in reality, the concept of absolute rest is impossible to achieve, because Earth is continuously in motion around the sun, it is revolving around the sun, rotating about its own axis. So the Earth is always in motion. So the Earth as the frame of reference, which we have already chosen for our measurements in mechanics, it is always in motion. So we can never achieve the condition of absolute rest. It is not possible. Absolute rest is not possible. Okay, we can never achieve the situation of absolute rest, because Earth, which is the frame of reference, which is chosen for all the measurements, it is always in motion. Because we know that our solar system, it is drifting in our galaxy, the Milky Way, all the galaxies in the universe, they are also in motion. So we cannot find any point in the universe which is at rest, absolute rest. Okay, so here the person is also actually in motion along with Earth. The box is also in motion along with Earth, because the frame of reference, that is ground, the Earth, it is in motion. But for this, if we only consider the person and the box, then yes, there is the we can say that it is a condition of absolute rest with respect to this box and the person, because they are both stationary. Then we have the concept of relative rest. So here, if the frame of reference and the body, they move with the same velocity. So here we'll use another example. Here I have also used this example in the previous video. Let's say we have two boys who are running with the same velocity or same speed. Okay, they are running with the same speed. So in this case, we can choose either one as the reference and the other as the focus or the object. Okay, so here, since both of them are moving with the same velocity, then it creates an illusion kind of a thing that they are both at rest. Because they are moving with the same velocity, the gap between them always stays the same, nobody catches up to another. So it always seems as if they are at rest, as if they are standing at rest at a gap of this, let's say, d meters. Okay, and even if they are moving with the same velocity, the gap always stays the same, and it creates an illusion that they are at rest. So if the frame of reference and the object, they move with same velocity, then it creates an illusion of rest. So here the concept of relative velocity comes into play, which we'll discuss after we have discussed some important parameters related to it. Then we'll discuss the concept of relative velocity. So this is relative rest, that is both the frame of reference and the object under study, they are they are moving at the same velocity with respect to each other. Okay, so here we have, since as we have described absolute and relative rest, we'll also describe absolute and relative motion. So first is absolute motion. If the frame of reference is at absolute rest and the body is in motion, it is said to be in absolute motion. Again, this situation is impossible because we cannot find any point on Earth or in outer space which is at absolute rest, because Earth is moving, all the points in the galaxy, they are moving away from each other, drifting away from each other, so everything is motion. Okay, so we cannot find the condition of absolute motion because none of the frame of reference is stationary, none of them is at absolute rest. So it is only a theoretical concept, not a practical one. Then relative motion. If both the frame of reference and the object under study, they are in motion with different velocities, okay, not with the same velocity, different velocities, then it is called as relative motion. Okay, here the same example which we described previously, if one of the boys is moving with a velocity v1 and another boy is moving with velocity v2 and they are both different, let's say v1 is greater than v2 or v2 is greater than v1, both the cases. So when v1 is greater than v2, so this boy A will finally catch boy B because it's the velocity, his velocity is greater than B's velocity. Similarly, if v2 is greater than v1, then boy A will never be able to catch v2, okay, unless and until he gets exhausted or tired and rolls down on the ground, that is a different case. But if he maintains the same velocity, both of them maintain the same velocity and do not accelerate, then he will never be able to catch. So they are moving with different velocities. Another case, both of them moving in the same direction with different velocities, that will also be relative motion. Also, if one of them is stationary and another, okay, let's say v2 is 0 and v1 is some non-zero value, then also it is relative motion. Okay, because v2 is 0, okay, but still if we consider the frame of reference Earth which is moving, so this object B is also in motion along with Earth, so it is in relative motion since none of the points it is at absolute rest. So this is the concept of relative motion. So again, absolute rest and absolute motion, that is not possible. Okay, the concept of absolute motion and the concept of absolute rest is not possible because it both requires a frame of reference which is at absolute rest, which is practically not possible. A frame of reference which is at absolute rest is not possible. Always remember it. Not possible. So absolute motion and absolute rest, these two cases are non-existent. All we have is relative rest and relative motion. Okay. So then another way to classify motion is one-dimensional, two-dimensional and three-dimensional motion. So like I said, we use the Cartesian coordinate system to quantify, measure the movement, the magnitude, direction, everything. So here origin is the point of reference. Then we have motion along x, y and z axis. Let's say we have an object which moves in only x axis, okay, only x axis, not in y axis or z axis. This is an example of one-dimensional motion. If it moves only in y axis, also this is one-dimensional motion. If the point it moves only in the z axis, that is also one-dimensional motion. Okay, this is one dimensional motion. Only along one of the horizontal axis movement is happening. Let's say we have another case where the object, it moves in the xy plane. Okay, it moves in the xy plane. This is the xy plane. In this case, both the x coordinates and the y coordinates, it changes. So this is two-dimensional motion. Similarly, if it moves in the yz plane, here both the y and z coordinates, it changes. That is also two-dimensional motion. Similarly, if it moves in the xz plane, here also the z coordinates and the x coordinates, it changes. So this is also two-dimensional motion. Now three-dimensional motion will be very difficult to show you. So let us say I use a different pen. Okay, we have there's x, y, z. So we have a point. Okay, we have a point. It starts from the origin, reaches point x, okay, this point on the x-axis, then moves in this direction, and then it moves in this direction here. So this point here is a point on the three-dimensional axis, 3D. Okay, so here this is example of three-dimensional motion, where both the x, y and z, three coordinates, they change. So this is an example of three-dimensional motion. So when motion happens only in one of the coordinate axis, in one dimension, x, y or z, only x, y, only x, only y, only z, one dimensional. When it happens in any of the planes, one plane only, x, y, y, z or x, z, it is two-dimensional because two coordinate axes change. And when it happens in, involving all the three axes, movement along all of the three axes, then it is three-dimensional motion. Again, we can understand motion in terms of translatory, rotational and oscillatory motion. Okay, so let us try to understand. So translatory motion, rotational motion and oscillatory motion. So a body is said to have translational motion or translatory motion if each particle of a body has the same displacement in the same time. So a person walking on the road, okay, it is translatory motion. A vehicle moving on the road, it has translatory motion. Okay, or a car moving on the ground, that is translatory motion, because all the points on that object, they cover equal distances in equal interval of time from their starting point. Okay, so when it happens in one dimensional, it is called as rectilinear motion in a straight line. A single point or object or a point mass moving in a straight line is called as rectilinear motion, which is the translatory motion. Okay, so this is basically linear movement. Okay, then we have rotational motion. So when a body, it moves or rotates such that the distance of that on the outer surface, it remains fixed. Okay, it remains fixed from that center point, that is called as rotational motion. Okay, so here all the particles on the body except those on the axis of rotation, they traverse a circular path. they traverse a circular path except those on the axis. Let's say we have a ball which is rolling down on the ground. This is circular motion. Or we have a door which opens or closes. This is circular motion. Okay, the movement of a screw. Okay, when we try to rotate it in clockwise or anti-clockwise direction, this is circular motion. So here the hinge to which it is attached, this door, that is the axis, that does not have a circular motion. Here this, the axis which passes through the center of the screw, that does not rotate, it remains at one point, it does not cover a circular path. This is the axis of rotation. Okay, here another interesting example. Here in this vehicle, the vehicle in its totality, it is covering translatory motion, but the tires, they are having rotational motion because they are rotating forward. Okay, so tires have rotational motion and the vehicle along with all the passengers inside, they have translational motion. Then we have oscillatory motion. So oscillatory motion is basically we have an object and it undergoes to and fro movement like this, then back like this, then again from here to here, then from here to here, like this. It undergoes to and fro movement about this center or mean position, which is located at equal distance on either side of this. Okay, this is the mean position or center position and it undergoes to and fro movement like this. Okay. So here some examples of this. One popular example is the pendulum swing. Okay, this is an example. Then U-tube manometer, the manometer liquid which oscillates or vibrates about one mean position, vibration of atoms or molecules in an object. So these are all examples of oscillatory or vibratory motion. So here we have tried to make you understand the concept of rest and motion. So here when you say, just say that an object is at rest or an object is motion, it is not that simple. You have to specify what kind of rest position is this, whether it is relative rest or relative motion, because the concept of absolute rest and absolute motion is non-existent. Similarly, when you say that an object is in motion, you have to say what kind of motion it is, absolute motion, relative motion, in what kind of motion it is, along which direction, one dimensional, two dimensional, three dimensional, and what kind of motion it is, rotational, translational, oscillatory, what. There are different ways in which you have to specify. Okay, so these are some of the basic concepts related to the concept of rest and motion. So, okay.